Greetings. My name is Barry Blend. I'm the presenter of the chi-square test of independence. The intent of this presentation is to carry out a chi-square test of independence utilizing PSPP, importing the data, stating the hypothesis test, rejection rule, and supporting information. Use PSPP to conduct the chi-square test of independence, examine PSPP's output, APA write-ups, and the takeaways. Importing the data. We have the data in front of us with all the values. Stating the hypothesis. The null hypothesis is there is no correlation between the first definite variable and the second definite variable. Alternate is there is a correlation between the first definite variable and the second definite variable. The rejection rule here is for us to reject the null hypothesis if P is greater than alpha, where alpha equals to 0.05. Post hoc rule is for us to reject the null hypothesis at the same time follow with Cramer's V. Note, the chief point is for the chi-square to tell us if or not there is a correlation, whereas the Cramer's V will tell us how strong is the correlation, or rather relationship. We're going to perform the test of independence for the following. We perform the test of independence for the following. The first is the chi-square test for the norm cars versus the norm default. The second is the chi-square test for the limb comfort versus the norm default. The third chi-square test is the norm cars versus the limb comfort. Stating the hypothesis. Before we begin, we have to state some important information. The norm cars is the number of car payments per month. The norm default is if no number of bands, if detail defaults to 1. Let's write out the first test. Stating the hypothesis, the null, as we've said already, there is no correlation between the norm cars and the norm defaults. Alternate, there is a correlation between the norm cars and the norm defaults. The rejection rule will be we reject the null hypothesis if P is greater than alpha, where the value of alpha equals to 0.05. Post hoc rule, if we reject the null hypothesis, then we must follow immediately with measurement of Cramer's V. What is the research question here? Is there a correlation between the norm cars and the norm default? Thus, how strong is the relationship? The breakdown. In order to do this, we're always going to do the independence test for norm cars and norm defaults. Here, this time around, we're going to go under analyze, descriptive statistics, and the crosstabs. The independence test for norm cars and norm defaults, we're going to go under the crosstabs. We're going to, choose the values that we intend to use. Click on the statistics, and voila, we arrive at the values that we need. Again, these are values. These are most of the things we're going to be using is like, for example, where you have the n, which is 150. Independent test for norm cars and norm defaults. The steps to follow are as follows, which I've already explained, but I'm going to go over it again one more time, is to analyze and go to descriptive, then all the way to crosstabs. When it pops up, under rows, insert norm cars. Under columns, we're going to insert the norm defaults. This means setting the variables in place. Afterwards, click the statistic button, then turn on the chi-square and the phi, which is the Cramer's V, then hit continue, and finally hit the OK to run the required test, which we've already carried out. For this, the first test, the Fourier correlation test was conducted. There is no correlation between norm cars and the norm defaults. There is a relationship between norm cars and norm defaults. The chi-square statistics and its p-value were calculated using PSPP, assuming alpha equals to 0.05. A relationship emerged. You can see the x squared bracket open 9 comma, n equals to 150, we have a value of 9.70, p equals to 0.15. With this, according to Cramer's V interpretations, which is at the bottom of this slide, the strength association of 0.15 to 0.20 suggested that Cramer's V indicated very weak relationship. This is the minimum strength needed to claim a relationship. The independent tests for leak comfort and norm defaults. The steps to follow are described as well. I'm not going to go over that. We already went over that, but we're going to move further. We have the values that we're looking for. Same thing, which is the second hypothesis. The following correlational test was conducted. There is no relationship between leak comfort and norm defaults. There is a relationship between leak comfort and norm defaults. Here again, the chi-square statistics and its p-value were calculated using PSPP, assuming alpha equals to 0.05. A relationship emerged in this situation where bracket open x squared bracket 9 comma n equals to 150 bracket close equals to 9.70 comma p equals to 0.375 comma v equals to 0.15. Cramer's V indicated a very weak relationship. Now we're going to go further. According to Cramer's interpretations again, the strength association V of 0.15 to 0.20 suggested that Cramer's V indicated very weak relationship. This is the minimum strength needed to claim a relationship. These are all based on the table of Cramer's V interpretational table. Independent tests for non-cars and leak comfort. The steps as well, we're going to follow those steps, and which takes us to the next, to our values, our crosstabs. Just further down, showing us more values. Now, we're going to do the third and the final test here. The following correlational test was conducted. There is no relationship between norm cars and leak comfort. There is a relationship between norm cars and leak comfort. The chi-square statistics and its p-value were calculated using PSPP, assuming alpha equals to 0.05. A relationship emerged, and we have these values here. But important enough here is the p is equal to 0.000. The v is equals to 1.00. Based on this, Cramer's V indicated a very strong relationship, which takes me to the next slide. According to Cramer's V interpretational table, the strength association of 1.00 suggested that Cramer's V indicated very strong relationship, which is perfectly symmetric in nature. Very rare. The independent variable perfectly predicts the dependent variable. This is where we got our relationships from, our interpretations from. 0.15 to 0.20, weak. A 1 is perfectly symmetric. So that's where we got those values from. Those values didn't just appear by itself. Now, the takeaways here is the chi-square statistics is an analytical tool that may be used to establish considerable information about the nature of research data. The chi-square statistic allows researchers to perform hypothesis tests in regards to variables being calculated at the nominal level. The chi-square is also an excellent tool to use when violations of assumptions of equal variances and homoscedasticity are violated, and parametric statistics such as the t-test and ANOVA cannot provide reliable results. Cramer's V is more like relationship for nominal variables. In other words, a number between 0 and 1, which allows how strongly two tentative variables are related in nature. Statistically, Cramer's V is based off Pearson's chi-square statistics. As the chi-square and the strength test, the Cramer's V are both simple to compute. It's an especially convenient tool for researchers in a field where statistical progress may not be easily assessed. Thank you for taking the good time in reading, watching my presentation, and have a nice day.